All right, let's get to the heart of chemistry. The thought process you are about to engage in, if you can understand what I am about to do in this lecture, then you can understand and perform 90% of the work that you're going to be given during the course of this semester. That's right, the same thought process we're going to use in this lecture to convert from millimeters to meter is the same thought process you're going to use to go from grams of methane to kilojoules of energy. So, without further ado, let's start our journey through unit conversions. Let's review what we've already talked about when it comes to the metric system. The reason the metric system is so awesome and so beloved by scientists everywhere is the fact that we can make larger or smaller units using prefixes. Those prefixes denote multiplying or dividing by powers of 10. For example, if we deal with simply length, the base unit of length is a meter. If I want to make a unit that's 1,000 times the size of a meter, I simply add the prefix kilo to make a kilometer, which is 1,000 times the distance represented by my base unit. If I want to make a smaller unit, let's say I want to make a unit that's 100 times smaller, I simply add the prefix centimeter, and I know that 1 centimeter is 10 to the negative second meters. Remember, multiplying by a power of 10 with a negative prefix is the same thing as dividing by that positive power of 10. If you can memorize your prefixes, you can memorize the relationship between any metric units, even if you don't know what those units are. If you memorize your prefixes, you can know the relationship between kilojoules and joules. Totally different from English Standard, right? English Standard is completely random. I mean, 12 inches equals 1 foot just because 36 pieces of corn equaled the length of some dead king's foot. I mean, it's a completely random system. 16 ounces equals 1 pound. You'd spend your entire life trying to memorize all these funky, unusual relationships that were presented within the English Standard System. That's why the metric system rocks, and the English Standard System is a beast. Matter of fact, the Beast is one of my favorite X-Men, so why don't you write down the Beast right now? Write down the Beast right now. Beast. B-E-A-S-T. Beast. Alright, here is a list of all your metric prefixes and the power of 10 they represent. You are responsible for knowing and memorizing everything on this chart. Let me say again, you're responsible for memorizing and knowing everything on this chart. You need to memorize that the prefix giga is represented by the capital letter G and means you multiply by 10 to the positive ninth. These are really easy to remember. Chances are you already know them. Alright. Let's start by talking about how I have this chart organized. I have this chart organized so that your base unit would be right here. Units larger than the base unit, in other words, positive powers of 10, are above the base unit. Units that are smaller than the base unit, in other words, multiplying by a negative power of 10, are below the base unit. Deca, capital letter D, is 10. How many years in a decade? 10. Kilo, 10 to the third, don't have a good one for that one. Mega, capital M, 10 to the sixth. Well, we all remember that Dr. Evil wants $1 million. And we've all played Mega Million Lottery lots of times, right? Mega Millions Lottery. All right. Then we've got Giga, and I don't have a good one for a Giga and a billion. Then we've got deci, lowercase d. Deci reminds me of dime, which is a tenth of a dollar. Centi is a hundredth. What do we call a hundredth of a dollar? We call it a cent. So centi. Milli is a thousandth. There are 1,000 years in a millennium, so a thousandth of a millennium would be whatever. That's how I keep milli straight. Micro, and here's my Dr. Evil. I was getting ahead of myself with my Dr. Evil because, I don't know, I was watching Austin Powers again last night, and I think that's a highly underrated movie. So is how I married an axe murderer, in case you've never seen that one as well. Micro, Dr. Evil had a microbane, and he always wanted $1 million. So micro is a millionth. Nano, N, negative 9, all begin with the letter N. Pico is Spanish for small. Femto, F, and 15 all begin with the letter F. All right, there, good. You just memorized them, or at least I hope you did. How do we use this chart? How does this chart tell us the relationships? Let's take a look at an example. If I wanted to know the relationship between gigameters and meters, I have this chart arranged so that one always goes with the prefix, and the power of 10 with the base unit. So 1 always goes with the prefix, and the power of 10 goes with the base unit. So if I'm wanting the relationship between gigameters and meters, I'm going to write 1, then my prefixed unit, and what's the power of 10 that base unit represents? 10 to the 9th. So it would be 10 to the 9th meters. The reason the 1 always goes with the prefix is this prefix is another way of saying that power of 10. When I say this relationship, what I'm really saying here is I'm saying 1 I'm really saying the same thing. That's why it's an equal sign, right? That G there represents that power of 10 to the 9th there. These are other ways of saying the exact same thing. So if I incorrectly wrote that, I'd be saying 10 to the 9th times 10 to the 9th meters equals 1 meter, which isn't correct, right? This prefix represents that power of 10. And I'm going to erase that before you even dare to let that enter your consciousness, right? So if you memorize your base units, if you memorize those prefixes, it's really easy to know the relationship between any two units. For example, if I asked you, well, let's clean things up here a little bit. All right, so if I were to ask you, what is the relationship between femtojoules and joules, first thing you might do is panic. I don't know what a joule is. I don't know what a joule is. You don't need to. We'll address that later before we're through the lectures for this test. But you don't really need to know what a joule is. All you need to know is what a femto is. You know that a femto is 10 to the negative 15th. You know that 1 always goes in front of the prefix, and the power of 10 from the chart always goes in front of the base unit. So 1 femtojoule is 10 to the negative 15th joules. Chemistry's easy, life is hard. Just to make sure this horse is thoroughly dead, if I asked you the relationship between kilograms and grams, you'd know to put a 1 in front of the prefixed unit. You'd know to write the power of 10 in front of the base unit. In this case, a kilo is 10 to the third. Let's do one more because I am having fun. If I asked you the relationship between picopascals and pascals, you're saying, what's a pascal? It's a unit of pressure. But again, you don't need to know that. All you need to know is that 1 goes in front of the base unit, and that a pico is 10 to the negative 12th. So 1 picopascal is 10 to the negative 12th pascals. If you know these prefixes, you can write an equality between any two units. The reason you want to know these equalities between units is because they serve as the basis for doing unit conversions. Let's take a look at the simplest unit conversion we can possibly do. How many millimeters in 4.2 meters? There are a couple easy steps that will let you solve any unit conversion out there. Step 1, write what you know about the units. What do I know about millimeters and meters? Well, the only thing I know about millimeters and meters is that 1 millimeter is equal to 10 to the negative third meters. Where did that come from? Straight off that chart that you've been working so hard to memorize, even though you just meant it 10 seconds ago. Matter of fact, if you don't have that chart memorized, I would pause me right now, print it off, and then come back and finish listening to the lecture. That chart may be provided to you in a slightly different format depending on how I'm feeling that semester and providing you with your handouts, but you have that metric conversion chart there somewhere. All right, so how many millimeters in 4.2 meters? All right, so we know our relationship now between millimeters and meters. Step 2 is we're going to start our line. The line is our friend. The line is awesome. The line will let us work just about any single problem in chemistry. The hard part of most problems is figuring out where to start your line. In this scenario, we only have one number. Since we only have one number in our problem, we're going to start our line with that number. So I'm going to write 4.2 meters, and I'm going to draw a line underneath it and another line next to it. That's horizontal. This horizontal line represents a division symbol. This vertical line represents a multiplication symbol. My next step is I'm going to place units where they cancel out. Meaning that if I have a unit of meters right here that I'm wanting to get rid of, I'm going to place them down here so that they'll cancel out. Whatever unit I have here, in 90% of the problems you're going to work, is automatically going to go down there. You don't even really need to think about it, because you want to place those units where they divide out. Right? Meters divided by meters is 1. Any number divided by itself is 1. Any letter or unit divided by itself is 1. So by placing my meters down here below my division symbols, I'm having them divide out. Now, whatever I have immediately above and below each other on this line has to be equal to each other. Must equal each other. Whatever is above or below each other on the line must equal each other. Let me clean things up a little bit here. Whatever is above or below each other on the line must equal each other. And I'm going to erase that now to make things a little bit neater. Or maybe I'm not going to erase things. All right. I have meters down here. I have to place something equal to meters on top of it. What do I know about meters? I know that 10 to the negative third meters equals 1 millimeter. So I'm going to write that relationship. I have meters where they cancel out. I place millimeters where they'll be left. I keep the numbers with their units. I have a 1 here, 10 to the negative third there. So I'm going to place my 1 in front of my millimeters and a 10 to the negative third in front of my meters. So now I'm going to multiply everything on top, divide through by everything on the bottom, and of course you don't really need to grab your calculators for this one. (4.2 times 10 to the third millimeters). Let's take a look at another one. How many picometers in 6.0 times 10 to the negative fourth meters? Step 1, write what I know about the units. I know at this point that 1 picometer is 10 to the negative 12 meters. How do I know that? I've memorized it. Step 2, start my line with the only thing available to me. So I've got 6.0 times 10 to the negative fourth meters. I want to place meters where they'll cancel out. I want picometers. I keep the numbers with their units. I multiply everything on top and I divide through by everything on the bottom. And that gives me all right, couple things. If you don't know how to get this into your calculator, I've got an instructional video posted online after this on how to use your class-approved calculator to get these numbers out. If you don't want to use your calculator, quick algebra review. I think I might have even done this algebra review elsewhere, but let's do it again. Remember, 10 to the x power times 10 to the y power equals 10 to the x plus y power. 10 to the x divided by 10 to the y equals 10 to the x minus y power. What these formulas have to do with our example up here is we have a scenario where we're dividing one power of 10 by another. So we're dividing really 6.0 times 10 to the negative 4th divided by 10 to the negative 12th. So 10 to the negative 4th divided by 10 to the negative 12th is 10 to the negative 4th minus a negative 12. And remember, minusing a negative is the same thing as adding a positive, or 8. And that's how I was able to arrive at that answer up there. Okay. If the line is confusing you and what I'm doing in terms of writing the line is confusing you, let me write it another way. What I'm really doing by writing this line is I'm writing a ratio. I'm really saying 6.0 times 10 to the 4th meters times the ratio of meters to picometers. All I've done really is I've run my division sign here into my multiplication sign and kind of tilted it on an axis, right? See, here's my multiplication sign right there, and there's my division sign and my ratio, just in case you're having trouble with comprehending what I'm doing with this line formatting. All right, what I want you to do right now is write down Angel, one of the most confusing X-Men ever, simply because they can't decide on his identity all the time. His secret identity is always the same, but sometimes he's Archangel, sometimes he's Angel, sometimes he's blue, sometimes he's not blue, sometimes he has feather wings, sometimes he has metal wings. Angel. Why don't you write down Angel? A-N-G-E-L. All right. How many joules in 3.3 times 10 to the 18th microjoules? Same process here. The only reason, matter of fact, the only thing that's different about this problem is notice for the first time we're converting out of the prefix and into the base unit. So write what we know. I know that 1 microjoule is 10 to the negative 6 joules. To start my line, I'm going to use my 3.3 times 10 to the 18th microjoules. I'm going to place microjoules where they cancel out. I want joules. Keep your numbers with their units. I have a 1 in front of microjoules, so I have a 1 there. I have a 10 to the negative 6 in front of joules, so I have a 10 to the negative 6 there. My microjoules have canceled out. I have units of joules, which is what I'm wanting. Multiply everything on top, divide through by everything on the bottom, and I get 33 times 10 to the 12th joules. Again, just from a power of 10 perspective here, 18 plus a negative 6 is 12, because 10x times 10y equals 10 to the x plus y. All right. So no differently when we're going to the larger unit from the smaller unit. Let's make this a Texas two-step now. Let's really kick this up a notch. All right, just a slightly twisted version of the equation we just worked. How many kilojoules in 3.3 times 10 to the 18th joules? Once again, we're going to write what we know. Ooh, for me that's going to be a short sentence. Oh, did I say that out loud? At any rate, write what we know about our units. Oh, doop, 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 doop. Write what we know about our, actually no, nope, I forgot something. I didn't want to make this joules, I wanted to make this back to our picojoules here. All right, picojoules, right? How many kilojoules in 3.33 times 10 to the 18th picojoules? Now we get to do a Texas two-step. Do we have memorized a relationship between picojoules and kilojoules? No, we don't. We don't have a relationship memorized between those two units. So we have to write what we know about each of those individual units. I know that 1 kilojoule is equal to 10 to the 3rd joules, and I know that 1 picojoule is 10 to the negative 12th joules. Now I'm going to start my line. 3.33 times 10 to the 18th picojoules. I'm going to place picojoules where they cancel out. Whatever unit I have here goes down there. What do I know about picojoules? Well, the only thing I know about picojoules is the relationship to joules. So, even if I don't know if it'll do me any good, even if I have no idea why I'm doing it, I'm hoping for partial credit, and I'm going to do something that I know I can do, and that's cancel out my picojoules. So I've gone from having units of picojoules to units of joules. Now, I don't want units of joules. That's not what they're asking for in the equation. So I know that my joules have to disappear. So I'm going to place my joules where they cancel out. What do I know about joules? Well, I know the relationship to picojoules, but I just used that, so that's not going to do me any good. The only other thing I have listed about joules and the units in the problem is the relationship between kilojoules. So I can go to joules to kilojoules. Hey! What do you know? That happens to be what they're asking for. Imagine that. I now have the units that they're asking for up on top. So I must be at my last step. Keep the numbers with their units. I have a 1 in front of kilojoules and a 10 to the third in front of joules. So now I'm going to multiply everything on top, and I'm going to divide by everything on the bottom. And that gives me 3.33 to 10 to the 18 plus a negative 12 minus a positive 3, or 3.33 times 10 to the third kilojoules. Chemistry's easy, life is hard, yes? Alright, let's keep this party going. How many centigrams in 4.2222 times, did I say the right number of 2's, times 10 to the third megagrams? Matter of fact, since this is the exact same process as last time, why don't you pause me, work it out yourself, then unpause me, and see if we did it the same way. I bet you didn't pause me. I bet you just kept on listening because you want to get this lecture over with. Ha! Please pause me for a second. Okay, Scout's honor, I hope you paused me. Even though if you didn't pause me the first time, I doubt you did on the second asking. Alright, how many centigrams in 4.222 times 10 to the third megagrams? Write the relationships you know about the units. You don't know a direct relationship between centigrams and megagrams, but you know that 1 centigram is 10 to the negative second grams, and you know that 1 megagram, that's a capital M, is 10 to the 6th grams, mega million after all. Next, start your line with the only number they've given you in the problem. Next, place whatever unit you have here down there directly. So I have megagrams up there. I'm going to place megagrams where they'll cancel out. The only thing I know about megagrams is the relationship to gram. Keep their units with their numbers. I've canceled out megagrams. Now I want to cancel out my grams, because I don't want them. That's not what the question's asking for. The question isn't asking for grams, it's asking for centigrams. I know the relationship between grams and centigrams. I have my grams where they cancel out. Place my centigrams where they'll be left. Keep the numbers with their units. Multiply by everything on top. Divide through by everything on the bottom. And I get 4.22 times 10 to the 7th, no, wait, 9th centigram. Wait, no, not 9th, 11th. I can't do basic math today. Woohoo! 10 to the 11th, right? 9 minus negative 2 is 11. 10 to the 11th centigrams. Chemistry's easy, life is hard. Matter of fact, life is really hard if you're rogue. Why don't you write down rogue? R-O-G-U-E. Rogue. Life is really hard because, you know, she can't touch anybody or else she'll, like, absorb their essence, their powers, and kill them, so it's really rough to be her. Alright, next example. We have to limit ourselves to just going through conversions from one metric unit or one SI unit to another unit. We can spice things up by throwing in some of those illogically fun English standard units. For example, I could ask you how many grams in 5.51 pounds. Now, I will always give you the relationship between the English standard and the metric unit because I don't expect you to memorize those. In this case, I'm telling you that 1 kilogram is 2.2046 pounds. All right, before we begin, we need to ask ourselves, do we know anything else here? Well, in my problem, I noticed that I have kilograms and I have grams. Do I know a relationship between those two? Yeah, they try to hide their affection for each other, but I know they're in a relationship. And I know that that relationship states that 1 kilogram equals 10 to the 3rd grams. All right, so what am I going to do? I'm going to start my line with the only number in my problem, 5.51 pounds. I don't want pounds, so my next step is going to be to get rid of them. What do I know about pounds? Well, the only thing I've been given about pounds is their relationship to kilograms. I know that 1 kilogram is equivalent to 2.20462 pounds. So now I've canceled out my pounds, and I have units of kilograms. I don't want units of kilograms, so I'm going to place them where they cancel out. What do I know about kilograms? I know the relationship to grams, which, hey, happens to be the unit I'm wanting. And I know that that relationship tells me that 1 kilogram is 10 to the 3rd grams. So I'm going to multiply everything on top, divide through by everything on the bottom, and here's where the real fun begins, because we're going to take our calculator out for the first time today, and we're going to type in 5.51 divided by 2.20462 times 1,000, or times 10 to the 3rd, and that gives me a calculator conundrum. It gives me a calculator lie of 2.49929969 times 10 to the 3rd. Or rather, if you don't have your calculators, actually I have my calculator set in scientific notation, so let me back up there a little bit and clean that up so that it looks more like what you're probably seeing. You're probably looking at your calculator screen and seeing 249.29631 grams. This is an outright calculator lie. But you knew that already before I even opened my mouth, because you're looking at the fact that we started with an initial measurement that only had 3 sig figs. That's right, we have to pay attention to sig figs when we're doing unit conversions. Now, the unit conversion from grams to kilograms is an exact relationship, meaning that 1 kilogram is exactly 10 to the third grams. When a relationship is exact, they have an infinite number of sig figs, meaning we don't need to take them into consideration when we're considering sig figs. Any unit conversion process, any unit conversion between 2 measurements in the same system is exact. Let me put that in writing for you. Any unit conversion relationship between units in the same measurement system is exact. That means they have an infinite number of sig figs, and that we don't have to worry about them when we're doing our unit conversions. So the only thing we'd have to worry about in this example here is the number of sig figs in our starting measurement, 3, and then the number of sig figs in unit conversions between measurement systems. When we go from kilograms to English Standard, we're switching systems, and therefore this quantity actually has to be measured. Whoops. Since this is a measured quantity, we have to take its number of sig figs into account. And by that, I'm not talking about the 1 there. We have to take the number of sig figs we have here, which in this case is 2, 3, 4, 5, 6 sig figs. 3 is the lesser number, so our answer should really only have 3 sig figs. 1, 2, 3. Remember, when you're rounding your sig figs, you can't destroy place value. So, 2. This 9 rounds to 10. And that's your best answer. Now, this answer does pose a dilemma in terms of sig figs, because that 0 right there is significant, while that 0 is insignificant. If only we had a way of writing that number to stress that. Oh, hey, we do. Scientific notation. If we were to put this in scientific notation, we could tell which 0 is significant. 2.50 times 10 to the 1, 2, 3. And that's a 3 there. I can't do 3s with the stylus, especially small ones. That wasn't any better, was it? All right, but that's a 3. By writing it in scientific notation, we can let people know what 0 is significant and what 1 is insignificant. Wow! That example covered more history than covered more information than Wolverine's history. Why don't you write down Wolverine, and then we'll look at another example. Wolverine. Everybody's writing down Wolverine. W-O-L-V-E-R-I-N. E. W-O-L-V-E-R-I-N-E. Let's look at this again, but less cluttered. How many ounces in 1.8 times 10 to the 6 micrograms? First thing, given that 1 pound is 2.205 kilograms. First thing again I'm going to do is I'm going to write down everything I know about the units in question. They've mentioned that I want to have my answer in ounces. Well, the only thing I know about ounces is that 16 ounces equals 1 pound. Then they mentioned micrograms. The only thing I know about micrograms is that 1 microgram is 10 to the negative 6 grams. All right, so let's start our party by writing the only number they gave us in the problem. (1.8 to the 6th micrograms Alright, I'm clueless as to how to solve this problem. I have no idea how I'm going to do it. However, I always remember that whatever unit I have right here, I automatically place down there. So that's exactly what I'm going to do. I'm going to place micrograms down here where they'll cancel out. The only thing I know about micrograms is the relationship to grams. And 1 microgram is 10 to the negative 6 grams. So I've gotten rid of micrograms, and I have grams. But grams aren't the unit I'm looking for. So I know my next step is going to involve placing grams where they'll cancel out. Well, what else do I know about grams? Let's see, is there another unit in this problem that's evolved from grams? Hey, yeah, there is. They mentioned kilograms in the problem. And I know that 1 kilogram is equal to 1,000 grams. So I can go from grams to kilograms. I'm not sure if it'll do me any good, but it'll at least let me do one more step, right? Because I have kilograms, so that means I can go to pounds. So I'm going to get rid of kilograms by placing them where they cancel out, and I'm going to go to pounds. And I know that 1 pound is 2.205 kilograms. I don't want pounds, though. That's not what the problem's asking for. It's asking for ounces. So I'm going to have to get rid of pounds. I'll place pounds down here where they cancel out. What do I know about pounds? I know their relationship to ounces. I know that 1 pound is 16 ounces. So I'm going to multiply everything on top and divide by everything on the bottom. And that's going to give me and that gives me 0.013061224 ounces as my calculator lie. Alright, so let's get rid of the calculator lie here and look at our sig figs. I've got 2 sig figs in my initial measurement. Here, I'm going from metric to metric, so it's exact. I'm going from metric to metric, so it's exact. So these 2 are exact, meaning I don't worry about them when I count my sig figs. When I go from pounds to ounces, I'm also going inter-English, right? Same metric system, same system, not metric system, same system, English to English. So that's an exact relationship. Here, however, I'm going between systems, so that's measured. And it looks like I've got 4 sig figs there. Which is the less number? 4, 2. 2 is the less number, so I should have 2 sig figs in my answer. 1, 2, round on the basis of that 0 and that 0 alone. And that gives me a final answer. Yes, Alex, my final answer is 0.013 ounces. Oh, no, I'm sorry. You should have said, what is 0.013 ounces? What this problem also shows you is there's nothing I can do to make these problems really difficult. All I can do is make them long. But if we take this problem one step at a time, doing what you know, following that sweeping pattern, it's really pretty easy. I don't think I've said it yet, but whenever we're dealing with a line, there'll be exceptions, but most of the time, it's going to be a situation where whatever unit you have here, goes down there. Whatever unit you have there goes down there and goes down there until you get the answer you want. And that makes chemistry easy and life hard. All right, let's do another problem. How many meters would a car travel in 33 minutes at a speed of 42 kilometers per hour? And some of you are saying, no, wait a second. No. That's an algebra question. You can't ask it in here. We hated those things in algebra class. Pfft, that's just because your algebra teacher didn't teach it right. This isn't an algebra problem. This is a unit conversion problem. The great thing about chemistry at this level in particular is that most of the time when you're given more than one number in a problem, one of those numbers will be the number you start your line with, and the other number will be a unit conversion. The hard part is determining which is the number to start your line with and which is the unit conversion. Fortunately, our good friend Chemistry Cat is here to help us out. Chemistry Cat is an expert at spotting unit conversions. Why? Because she's always reminding us about them. Because cats always say, purr, right? What do cats say? Cats say, purr, 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 which is your clue that you have a unit conversion. When we read our sentence, how many meters would a car travel in 33 minutes at a speed of 42 kilometers per an hour, we read that division sign as a per, right? Whenever you have a division sign like that, you pronounce it per, and that means you have a unit conversion. 42 kilometers per an hour is actually the relationship between distance and time. It tells you that you have 42 kilometers equal to 1 hour. And once you've identified your unit conversion, the problem becomes really simple. Because all you have to do is start your line with the other number. In this case, 33 minutes. All right, what do I know about minutes? I know that 1 minute is, whoops, that doesn't do me any good. I know that 60 minutes is 1 hour, and I know that 1 kilometer is 1,000 meters. So let's begin putting those pieces together. I have minutes. I'm going to place them where they cancel out. And I'm going to go from minutes to hours. So now I've canceled out my minutes, but I don't want hours. Fortunately, I have a relationship between hours and kilometers. So I know that in 1 hour I can travel 42 kilometers. I don't want kilometers though. That's not what they're asking about. So I'm going to place them where they cancel out. I want meters. According to the relationship, 1 kilometer is 10 to the third meters. And hey, that cancels out my kilometers, and I'm left with units of meters, which is the units I'm wanting, so I must be done. I grab my trusty calculator and I punch everything into it. 33 divided by 60 times 42 times 1,000 equals 23,000 meters. In terms of sig figs, I only started with 2, and I've got 2 there. So, and the other 2 things there are exact. So that means I should have 2 sig figs. So my answer is going to become 23. Don't destroy place value when you round. Right? We still want to have 23,000, not 23. So there's my answer. If I was going to put it in scientific notation, to get rid of those insignificant zeros, it would be 2.3 times 10 to the 1, 2, 3, 4, fourth meters. Good, right? Chemistry is easy, life is hard? No, wait, you're telling me that there's something wrong here, and I know exactly what it is, and I couldn't agree with you more. Chemistry cat is in lab without wearing safety goggles. Now everything's all good. Let's look at another example. Right, let's do another variation on the theme. This time just let's make the problem insanely long. Alright, once again we've got a problem, and our problem has two numbers in it. We just need to identify which one's the unit conversion. Well, Chemistry Cat helps us out with us because we can say 73 kilometers per an hour, right? So right away we know we have a relationship between kilometers and hours again. This time, however, our starting number is 4.9 times 10 to the 7th centimeters. In my first step, I have to get rid of centimeters. The only thing I've ever known about centimeters is their relationship to meters. I know that 1 centimeter is 10 to the negative second meters. I have meters, but I don't want meters. Whoops. What do I know about meters that might be related to something up here? Hey, I know the relationship between meters and kilometers. I know that 1 kilometer is 10 to the 3rd meters. I don't want kilometers, though. I want seconds. I know the relationship between kilometers and hours, so that means I can go from distance to time. We can do it one of two ways. I know that 1 hour is 60 minutes. And I know that 1 minute is 60 seconds. So now I just need to multiply everything on top, divide through everything on the bottom, and I punch that into my calculator, and I get this really long, big, hideous number, 24164.38 something, something, something out of my calculator. All right. Once again, I've got 2 sig figs here. Then I have a bunch of exact stuff. I've got exact down here. And then I have something that was measured here. And that measured has 2 sig figs. So my answer can only have 2 sig figs. I'm going to round on the basis of that 1. Remember, when you round, you can't destroy place value. All those numbers you round away, you have to replace with zeros if it's before the decimal. So I've got 24,000 seconds. Putting it in proper scientific notation, which you don't have to do unless the problem asks for it, would be 1, 2, 3, 4, 2.4 times 10 to the 4th seconds. Chemistry is easy, right? Life is hard, yes?